Going on to the last topic in Chapter 2 that we'll be doing, solving linear inequalities in one variable. Now, inequalities are solved very much in a similar way that equations are solved. But there are some specifics that we need to go over as background information. Now, there are 4 scenarios that we're going to look at here, and I have them all listed. One is actually in your booklet, but I'd like you to put these other 3 there as well, and you're going to make another number line, another number line, another number line, and one is already in our booklets. So we have 4 scenarios, and we'll have 4 number lines, and I want to graph each one of those. So let's call this one number 1, just so we can kind of keep track here. Now, as we read this, and these are what we call algebraic expressions. X is less than 1. X is less than or equal to 1. X is greater than 1. And in this case, X is greater or equal to 1. Now, all of these have a special way of being placed on a graph. And these down below is what you'll find in MATLAB, where you'll have to select it. These are 2 parentheses. These are 2 brackets. This is a parenthesis and a bracket. This is a bracket and a parenthesis. So one of the things you're going to look at is a solution like this, where X has some value in an inequality setting, and you'll need to pick out which set of symbols you want to put on this graph. And you click on that, and then the symbols appear on the graph. Then you have to move them around so that it reflects what is illustrated in the inequality example. So we're going to graph all 4 of these, and then you'll have it as a record. So for number 1, we're saying X is less than 1. So we go up here to where 1 is on the number line. And since it's less, we're going to use a parenthesis. I didn't quite get that in there. I got to do that one again. Try a little better this time here. Let's see here. There we go. And then we darken this line in, and then extend the arrow on this end. Now, the arrows are already there, so we're using for this one, and this goes out to negative infinity in this direction. Now in our book, or in our software, when we go to the very end of the line, 3 little dots appear, and these 3 dots are called an ellipsis. You want to write this in your notes as well. And that indicates the pattern continues to negative infinity. Whatever the ellipsis is, that pattern continues. Now, infinity always ends with, we don't know where it ends, so we use a parenthesis in a sense to close it. It indicates it's not being closed because of its infinity nature. So we have a parenthesis here, parenthesis here. Which one of these would you choose? Well, you'd choose the 2 parentheses. Now, one of the things they ask you is to put this in what is called interval notation. And write this down too. Now in interval notation, we can take it right from the graph that we're going to have a parenthesis. We're going to use the negative infinity, put a comma, and this goes up to a 1, but we use a parenthesis to indicate that the 1 is not included. All right, let's do number 2 now. It's very similar, but this says x is less than or equal to 1. So now 1 is included. So here we're going to use a bracket at 1, and it goes to negative infinity. So we use a parenthesis out there, and in our software you get the ellipsis, and this sort of fills in. So which of these would you use below? And if you said this one here, parenthesis and a bracket, that would be correct. So interval notation for number 2 here is parenthesis, comma, 1, bracket, right from the graph. All right, number 3. We're now saying that x is greater than 1. Now, because it's greater, the parenthesis, again, 1 is not included, is going to face to the right. And then this is going to positive infinity. And again, in our software, they use the ellipsis. But to put this one in interval notation, it's going to be a parenthesis, a 1, comma, and then positive infinity with a parenthesis. So which one of these would you use to put on your software? Again, it would be the 2 parentheses. Now for the actual example we're doing here, x is greater than or equal to 1. We'll use it here. It'll be a bracket facing right at 1, extending the line. It's going to positive infinity, and infinity always ends with a parenthesis. Putting this in interval notation now, it's bracket 1, and then a parenthesis. So we would use this symbol. Now when we click this sort of appears on the line, and we have to click and drag where we want. You can also use your arrow keys to help you place that. All right, this is background. Hopefully you have some good notes for this. So I'll illustrate then how to solve an inequality. And this actually shows the one difference there is from solving a regular equation to solving an inequality. So I want to get all the x's on one side. So here's kind of a stray x, so I'm going to transpose it. It becomes a negative 1x, so this side is a negative 4x. Now I'm going to take this 3, transpose it. On this side it becomes a negative 3, and this is then greater than 4. So I'm subtracting 3 there, subtracting 3 here. Now the major difference is whenever I have to divide or multiply an inequality by a negative value, to keep the statement true, I have to reverse the direction of the inequality sign. So I'm going to divide this by a negative 4 and this side by a negative 4. So here this becomes now a positive, and this becomes a negative 1. Now they're asking us to write this in interval notation. So I would suggest always is make a little graph, because that helps you to put it in interval notation. The number we're interested in is a negative 1. Now what symbol are we going to use here, a parenthesis or a bracket? And again, it's going to be a parenthesis that opens up to the left. Kind of missed that a little bit. There it is. and it looks like so. So for interval notation, I'm going to say this is coming from negative infinity, and negative infinity always has a parenthesis, comma, goes up to a -1, but because it's only less than -1, -1 is not included in the system, and we use a parenthesis. Okay, so rather easy. Key is, if you have to divide or multiply by a negative, as we did here, you have to reverse the direction of the inequality sign to keep it true. Now we briefly sketched the graph on the other page, so this is the place to put it. So you're going to use the parentheses at a -1, and then the ellipsis here, and that would be the graph when you do something like this using the Hawks software. Okay, let's solve this one. And we'll do this one together also. Take some notes as we do it. So first, clear parentheses. A -8z, a -10, just distributing, is less than a -2z plus 8. Now I want to get all the negatives or all the z's on one side. So as I transpose this, I don't have to change inequality signs yet, just transposing. That's the same as in an equation. This becomes a positive 2z, so this side is a -6z. I'm going to transpose the -10 to this side, where it becomes a positive 10. And 8 gives me an 18. Now, again, I'm dividing by a negative to isolate my z, dividing by a negative. So in order to keep this statement true, I have to reverse the direction of that inequality sign. So now I get z is less than a -3. Again, whenever you have to divide using inequalities, you have to change the direction of the inequality sign to keep the statement true. So to graph this now, I'm going to choose what? Well, it's an inequality only, so I'm going to use the parentheses at -3, and it says z is less, so I'm going to face it to the left, fill this in, and the ellipsis forms here, but this indicates -infinity. So putting this into interval notation that we're going to do here, -infinity, comma, a -3. On our next example here, we're going to take time to read it, and I've set it up here a little bit for you. Copy this down, and then see what you can figure out. Now, my question is, what do I put here in this spot right there? And let's see if somebody can volunteer that. And if you said 3t, that is correct. Now, my next thing I'd like you to do is to write this side of the equation. I've given you a hint, less than or equal to what they could spend. All right, let's pause again. So, we're going to have tomatoes at 160. This is the number of pounds of tomatoes. Now we need 3 times as much black beans, so this is going to be 3t, and black beans cost 170. Well, I didn't get that too straight, did I? But that's what we have. So you might suggest, what's our next step? Well, get rid of our decimals, I think would be a good idea. Multiplying every term by 100. And then solve it. And there we've multiplied through, gotten rid of the parentheses, combined like terms. And what is our answer statement? Well, at most, 4 pounds of tomatoes can be purchased. All right. All right, see if you can solve this and get the right inequality sign, and then put it on a graph and give the interval notation as well. All right, so you're going to divide both sides by a -4. So we get a positive x. I had to change the direction of our inequality sign, and this would be a -5 here. So we go to a -5 on our line. And again, you're clicking on which set of symbols to put it there. Well, since this also is equal as well as less than, we're going to use a parenthesis and a bracket, which I believe is this one right here. So here we use a bracket, and then for -infinity, we're going to use a parenthesis. So interval notation would be -infinity, comma, -5, bracket. All right, study this for a moment, and up in this area here, see if you can come up with some sort of inequality for this. So as you put this together, we're going to develop an average that is greater than 77. So this average here is greater than 77, but is less than or equal to 85. So this would be part of it, but I'm leaving something out. What have I left out? This is not an average yet. In order to make this an average, I have to take this and divide it by what? Well, 1, 2, 3, 4, 5, 6. I have to divide this by a 6. Now I want to get rid of that 6. How do I do that? Well, keeping in mind that this division bar is a grouping symbol, and in a sense this is all one term. If I multiply this one term by 6, these 6's will cancel out. But since I multiplied this by 6, I have to also multiply this by 6 and multiply this by 6. Okay, so let's see what you get. So something like this. This is 462 is less than this. I added these up plus the x. Now, how do I isolate the x in the middle? Well, here I'm going to go back to that older method where we're going to subtract 381 from this, subtract 381 from this, and subtract 381 from that. And then I end up with my answer, and that would be on this side is an 81. X is in the middle, and on this side it's 129. Now, generally you can get an 81 on a test, but you want to get an 82 to be in that category. So 82 would start here. And you don't get 129 on a test, but this is what the answer comes out. Okay. Now for number 7, it's going to be solved in a similar way as we would an equation. Let me bring it up, clear this up, and we'll ask you to see what you can do. We'll rewrite it. So going back to the earlier part of this chapter, we can put our big bracket out here, and we want to get rid of that fraction. So it's just a 2, so we're going to multiply everything by 2. So here, 2 times negative 7 is a negative 14, is less than or equal to. Now the 2 will cancel out. This will give you a 3z. 2 times 2 is plus 4, is less than 2 times a negative 4 is a negative 8. Okay, we've made it easier by getting rid of that fraction. Now we'll use the older method to isolate the z. Here I'm going to subtract 4, subtract 4, subtract 4. This now gives me a negative 18 is less than or equal to 3z is less than or equal to a negative 12. And as you probably imagine, you're going to divide everything by a 3 here to isolate the z. So this becomes a negative 6 is less than or equal to z is less than or equal to a negative 4. Now if we were to graph that, let's do the graph of that just to show you. There's a line, and I'm going to put some points on the line. There's my negative 6. There's my negative 4. And I'm going to use, I'll do it in black so we can see it, a bracket this way, a bracket this way, fill it in the center like so. And in interval notation, this would be, well, let's get a nice proper bracket there. Got carried away, I was doing so well. Bracket, negative 6, comma, negative 4, bracket. So if you were asked to graph this, you would choose the double bracket here. And then this is interval notation. This would be the algebraic solution. And that would be the graph. Okay, well this winds this up. We'll be going on to chapter 3 after our next lesson here.